In section 11.2, we're going to talk about box and whisker plots. So what does that mean? What is a box and whisker plot? Which some of you may have done and some of you may have not done. Well, a box and whisker plot is basically a way to represent data. So what you are going to learn is how to use a box and whisker plot to represent data sets, how to interpret box and whisker plots, and how to use box and whisker plots to compare data sets. Basically, this is a lot of drawing and a lot of using mean, median, and mode. So it's stuff that isn't that hard. Rather than actually going into a core concept, we're actually going to do an example, and we're going to talk our way through this. So I'm giving you a group of numbers. There are 8 numbers here. The first thing we always want to do is we want to organize them. We want to put them in order from least to greatest. So as we do that, we would start with 13. Actually, 12 looks like it goes first. 12, 13, then 15, 16. We have 2 18s, a 20, and a 24. So the first thing is always going to be just organizing the data so then we can attempt what we're going to do with it. So the first thing we got to do after we organize the data is we need to find the median. The median, as you remember, is the middle number. In this case, you will notice that we have 4 numbers to the left and 4 numbers to the right. The median is right in the middle. So the median, the middle number, is 17. Since we have 16 and 18. 16 and 18, they're our middle numbers. So we have to find the average. So we would take 16 plus 18. We would get 34 divided by 2 gives me the 17. Now from there, we've taken our data and we've separated it into 2 halves. This is called the lower half, and this is called the upper half. From there, we want to find the medians of each of those halves. So we're going to basically separate this all into fourths. So the median here would be taking these 2 numbers, 13 and 15, we would get 28, and we take the average. So it would be 14, would be the median of the lower set of data. In the upper set, we take the 2 middle numbers, divide by 2, the median would be 19. Now this essentially is your box, where the box and whisker comes from. This is our box from the first and last medians. So I'm going to show you what it kind of looks like on a number line. So on a number line, I'm just going to make some numbers here, 11, 12, and I'm going to continue on. So what's going to happen is this. Your box goes from the lower 14, the median from the lower part, which is 14, you put a dot there, and the upper part, which is 19. That's what makes your box. That is where most of our data occurs. Now in the middle, you're going to take the median, which is 17, and you draw a line, and that 17 represents the median of all of the data. Now from there, while most of the data is in the middle, we actually have a range that goes outside the box both ways. So what you have to do is look at your lowest value and your highest value. The lowest value is 12. This is what's called the whisker. That means the range of all this data goes from 12 to the left all the way to 24 on the right. And so that's how you construct a box and whisker plot. So let's go over our core concept now. Here it all is. Using a box and whisker plots to represent data. The box and whisker plot shows the variability of a data set along a number line using the least value, the greatest value, and the quartiles of the data. So what are quartiles? Quartiles are just when you take the data and divide it into 4 equal parts. The median, the second quartile, divides the data set into halves. The median of the lower half is called the first quartile, and the median of the upper half is called the third quartile. So it makes more sense now that we did one of these. The lowest part of the box is called the first quartile. This is the median of the lower half. The third quartile is the median of the upper half. Quartile 2 is the median of all of the data. And then your whisker is made by connecting your least value to the box and the box to the greatest value. The 5 numbers that make up a box and whisker plot are called the 5-number summary. 5-number summary. That's the least value, the median of the lower half, the median of all the data, the median of the upper half, and the greatest value. So let's look at example 1, making a box and whisker plot. Make a box and whisker plot that represents the ages of the members of a backpacking expedition into the mountains. Here's all of our data. We need to first put it in order from least to greatest. So here we go. Here's all of our data. You will notice that the median, in this case, the average of these two middle numbers would be 25. So remember, this is quartile 2. From there, all of these numbers are the lower half. All of these numbers are the upper half. The least value is 18. The greatest value is 30. Now the first quartile, which is Q1, is the median of both of these, the average. 28 and 30, the average of that is 29, so that's quarter 3. If we actually draw a number line, which I'll show you in a second, we're going to draw the number line. You're going to put your 5 dots, your 5-number summary, and then make your box and your whiskers. Here you go. The least value, 18, you put a dot on 18. Quartile 1, which is 23, you put a dot here. Quartile 2, which is your median, you put a dot here. Quartile 3, which is 29, you put a dot here. The greatest value, you put it here. So these are all your 5 points. You take your medians of the lower and upper half, and that's your box. And then your whiskers go out to your least value and your greatest value. The next thing we're going to talk about is how do you interpret this data? What does it mean? Well, here's what we look at. Here's our data. A half of all the data are in the box. A fourth of the data are in each whisker. That's it. A fourth of the data is below, a fourth of the data is higher, and the other half is in the box. So what does that mean? I mean this. This is a study tip. I'm going to make this a little smaller. There we go. A long whisker or box indicates the data is more spread out. So as you can see, it's more spread out on the left than it is on the right. So the longer whisker or box means the data is more spread out. Now another measure of variation for the data set is the interquartile range, otherwise called IQR, which is the difference of the third quartile, Q3, and the first quartile, Q1. It represents the range of the middle half. That's all it is. You take the box, you find the range of the middle half. You take quartile 3 minus quartile 1. All right, the box and whisker plot below represents the lengths in seconds of the songs played by a rock band at a concert. So obviously you can see 160 seconds is the shortest song, 300 is the biggest song. And then here's all of our information. A, find and interpret the range. Well, the range would be 300 minus 160. So the least value is 160, the greatest value is 300. We subtract them, we get 140 seconds. What does that mean? It means that the song lengths vary by no more than 140 seconds. So part B says, describe the distribution. That's talking about like a fourth of your data here, half of your data here, a fourth of your data here. So we have to look at it this way. Each whisker represents 25% of the data. So we know 25% of the songs are from 160 to 220 seconds. Half of the songs are from 220 seconds to 280 seconds. And the rest of the songs, the last 25%, are from 280 to 300 seconds. So I'm going to move these over here. And let's talk about C and D. C says, find and interpret the interquartile range. Now remember, the entire quartile range is where you subtract the first quartile and the third quartile, which is the median of the middle set of data. So here's what we mean. The interquartile range will be 60 seconds. You take 280 minus 220, you get 60. This means the middle half of the songs vary by no more than 60 seconds. The next part says, are the data more spread out below Q1 or above? Well, by looking at it, it's pretty easy to see that the whisker on the left is longer than the whisker on the right. So the data in Q1 is more spread out than Q3. Next is using the box and whisker plots to compare data. I'm going to go over this really quickly here, but the longer the whisker is on the left, that means your data is skewed left. Most of your data is on the left. If it's symmetric, the whiskers are equal, and the median is in the middle of the entire thing. This is symmetric. It is skewed right if more of your data is on the right whisker than the left. So if we're looking at example 3, the double box and whisker plot represents test scores for your class and your friend's class. A, identify the shape of each distribution. B, which test scores are more evenly spread out. Well, which shape of distribution are we talking about? Skewed left, skewed right, or symmetric? Well, if you look at your class, the whisker on the left is longer. So, because the whisker on the left is longer, this data would be skewed left. And the distribution for your friend's class, right here, it's symmetric. Which test scores are more spread out? Well, if we look at it, the range here, the interquartile range in your class are smaller, right here. The difference between the median here and the median here is smaller than your friend's class. Now, the test scores in your friend's class are more spread out. Look at this. Look at how much farther this is spread out than your class.